So today will be our kind of last day where we're just focusing strictly on kinematics graphs, the position versus time, velocity versus time graphs that we've been working on here for the last week or so. Tomorrow I will start acceleration, and then Wednesday we'll have another like kind of lab activity that we'll be doing. But this will be kind of our last day of just kind of plugging away at graphs, making sure that if you have questions, today's the day to ask. Okay, and then obviously you can still come in for help at any point along the way. But to access, I mean, I'll have the graph up here on the board, but it's kind of hard to see because it's not as big as it would be if you have it on your own device. Okay, so if you go to Google Classroom, it's in the post for today, which is already up. Okay, so if you go to this Google Doc right here, okay, because it's not actually in your worksheet booklet, I just threw it together this morning. Okay, you can see that the graph is there, and there's a bunch of questions to do with that graph. Okay, so questions 1 through 8 have to do with the position versus time graph, and then question number 9 has to do with the velocity versus time graph. All right, so that's what I want you guys working on here. Okay, like I say, I'll put the kind of big version of the graph up here, but you guys will need the questions on your phone most likely to get that done. Okay, and then if there's questions, we'll go over them together, or I can come and help you individually. Okay, we'll just work on that for today. All right, guys, I'm just going to go over a few from each kind of question here just to kind of clarify things in case anyone's having any trouble. Okay, so for question number 1, okay, for question number 1, we're asked to find what's the position at these various times. Well, since it's a position versus time graph, we can read those directly off the graph. Okay, all I have to do is look at, let's say, time 14 seconds. Okay, so I go to 14, I go up, and then I come over. Okay, and I'm going to find it's 25. Positive 25 meters, okay? For the total displacement, okay, so let's do total displacement to time 4 seconds. To calculate total displacement, I go final position minus initial position, okay? So all I have to do is put my marker on here on 4, okay? I know that my final position is positive 4, okay? My initial position was 30, okay, so I go 30 minus 4, and I've got a total displacement of negative 26 meters. Okay, everybody with me there? Okay, with question number 3. Okay, with question number 3, we have the total distance traveled for the same times as in question number 2. Okay, so if I want to calculate total distance traveled to time 4 seconds, now does direction matter? If it's distance. Distance is scalar. Doesn't care which way I went, which means I can't go final position minus initial position because that's not going to work. That's going to tell me this line. That's not the line I want. Okay, I want to know how far did this thing go over the entire part of this. So it went from 30 to 50, which is 20 meters, okay? And then it went from 50 to 4, which is 46 meters. So the total distance traveled is 66 meters. Okay, so remember with distance, you essentially have to add up all the sections, okay, in order to calculate how far it's gone in total. All right, then for question number 4, displacement or between these various times, pretty much the same as question number 2, except now your initial position is not going to be 30 for every single one of them. Okay, it'll be something different each time. So if we look at 4b, okay, between 4 and 8 seconds. Okay, so between 4 and 8 seconds. So at time 4, I'm right here at position 4 meters. Okay, and at time 8 seconds, I'm right here, which is negative 33. Okay, so negative 33 minus 4, okay, it's going to give me negative 37 meters. All right, everybody okay with that? Okay. And then looking at question number 5, okay, it's the distance traveled. So we basically just have to add up all the parts. Okay, so if we're looking at between 4 and 8 seconds, okay, it would just be the same thing, except now we would have to add the positive and the negative on. For a question, how many people are on to 6 doing velocity? Okay, so let's quick review of that. Okay, remember that velocity is the displacement over the time. So let's say between 2 and 4 seconds, we're looking for the velocity between 2 and 4 seconds. Okay, so we'll erase those 2 marks. At time 2 seconds, I'm right here at position 50. At time 4 seconds, I'm here at position 4 meters. Okay, so my displacement, or sorry, my velocity is my total displacement over my total time. That's final position minus initial position over time. Okay, so that'll be 4 minus 50 divided by the 2 seconds over which that happens. So we got 4 minus 50 is negative 26 over 2, negative 13 meters per second. Okay, so simply a V equals D over T calculation for those. Okay, all right, I'm going to give you a little bit more time to get a little further ahead of me, and then I'll do a few more examples from each, unless anyone has requests. Okay. Okay, because I can't do math today for some reason. Okay, this is supposed to be 46, not 26, and then this should be 23, not 13, because Codier's a doofus and can't do math today. Yeah, good catch. Okay, let's have a look at 9A. I think probably a few people are there where you're calculating the displacement of the object, the total displacement over the whole trip. Okay, so we have a velocity versus time graph, right? And what we have to be aware of is that we need, in order to calculate displacement, we need to take average velocity and multiply by time, and we've got to do that per section of the graph. Okay, so where it's changing, we'll have to calculate half the height of the triangle and multiply that by the base, because that will be the average velocity times the time. Okay, that'll give us essentially the area of all of these shapes, which just happens to give us also the displacement of the object during all of those parts. Okay, so what I've done is I've drawn on all the shapes that I used. You may have drawn different shapes. As long as you included all the area between the line and the x-axis, you're going to get the same number as I do, whether you made different shapes or not. Okay, so I've got this first little rectangle here that is 3 high by 3 wide, so its area is 9. Okay, and I've got this one here that goes from 3 to 13, so it's 10 high by 3 wide. Okay, so 10 times 3 is 30, over 2 is 15. Did I do that right? I'm reading that right? Yeah, 10 high. Yeah. And then I've got this big long rectangle here, okay, that goes from time 3 seconds to time 13 seconds. Okay, so that's going to give me 10 seconds along the base, and it is 12 high, so that should be 120. Okay, base times height, right? 12 by 10 by 12. And then I've got this triangle here that goes from 12 to 28, so it's 16 high, and it is 4 wide. Okay, so 16 times 4 is 50. Is that right? Is 60? Right, sorry. Is, yeah, 60, and then divide that by 2. This one should be 30. Okay, and then this one here is 16 high as well, but it's only 1.5 long. Okay, so 16 times 1.5 should give me 20. Is that right? No, 16 times 1.5 should give me 20. I should just stop guessing and use the calculator on here. Okay, so I've got 16 high, and it is it 1.5? Am I reading that right? No, that's not right. It's, yeah, it is 1.5 wide, right? Sorry guys, it's hard for me to see it because when I copy and paste it over, it doesn't show up as well as it shows up on your document. Why don't I look at it on your document? That might make my life easier. No, it didn't. Okay. So, wow, that's horrible. Three and a half, no, okay. Here's the one I'm looking for, right? Oh no, I'll do the whole thing. Okay, I'm gonna go 3.5 wide. I'm gonna do this whole, oh no, I already did this bottom part of the triangle. That's why I can't do it that way. Okay, so I've got this triangle here that is 2 wide. Sorry, it's 2 wide and 16 high. Okay. 2 wide by 16 high. Okay. So 2 times 16 is 32, divided by 2, that should be 16. Is 32? Did I misread that one? Oh, because it's 16. Mm-hmm. 32. All right. Then we've got this small triangle that is also 12 high and it is 1.5 wide. Okay, so we got 12 times 1.5. Okay, gives me 18 divided by 2. That should be 9. Okay, so this one here will be 9. And then I've got this triangle here that goes to negative 12. So it's actually the same size as this one, right? It's 1.5 on the bottom. So it's negative 9. Okay, then I've got this triangle here, okay, that is going to be 10 high by 5 wide. Okay, so that'll be 25, negative 25, because 50 times 10 over 2. Then I've got this triangle here that's 5 by 2. Okay, so it's negative 10. And then I've got this small triangle that is 2 high by 2 wide. So it's negative 2. All right, so if I add up all of those, keeping my negatives negative because it's wanting total displacement, I should get the answer that I have in there. All right, so let's go with 15 and 9. Okay, so 15 plus, not times, plus 9 plus 120 plus 32 plus 16 plus 9 minus 9. Could have just done without both of those. Okay, minus 25 minus 10 minus 2. Okay, I didn't get the same number I got the last time, 155. Did I mess one up somewhere? I'll have to look at my numbers again here, guys. But I mean, you got to calculate the area of all of those shapes. I must have missed one somewhere because I know I had a decimal when I did this the first time. Here, 13 point. Yeah, that's what it is. Yep. Right, because it is 10 high by. I misread that one. Yeah. But it's really hard to see it on that one. Okay. So does everyone follow or remember how we do that? Okay, with the areas. Obviously on a test, I wouldn't give you one that had this many sections. Okay, it's just so that we get practice doing it all. Obviously on tomorrow's quiz, it'll be a much smaller graph and it'll only have like 3 sections that are very obvious and a much more defined grid space to work with and all that kind of good stuff. Okay. And then from there, okay, you're taking the numbers that you calculate and you're calculating velocity or you're doing some acceleration calculations, things like that. But I'll let you get a little bit ahead of me before I do any more of those.